Hello again, this is my lab 4 based on oscillations. The primary objective of this lab is to predict the motion of an oscillating mass by employing data collected through tracker software. I will also create a computational model to replicate this motion. A key part of the analysis will involve examining different forms of energy within the system, including kinetic energy, gravitational potential energy, and elastic potential energy. The system under consideration includes the oscillating mass, the spring, and the earth. Applying the energy principle, the change in the system's energy is equivalent to the work done on the system by its surroundings, as well as any energy exchange. Given that the system includes the mass, spring, and earth, there is no external work being done on it. As a result, the total energy within the system is conserved. This implies that the changes in kinetic energy, gravitational potential energy, and elastic potential energy should sum to zero, confirming the principle of energy conservation. My experimental data collection involved using tracker software to track the motion of the oscillating mass. The software provided the x and y values representing the position of the mass. These data points were then converted into a CSV file format, which was used in the computational model. In the computational model, the initial conditions of the system are defined, including the mass, position, and velocity of the oscillating mass. Constants like gravitational acceleration, spring constant, and initial spring length are also set. The total energy is calculated by considering the kinetic energy, gravitational potential energy, and elastic potential energy. The net force on the mass, consisting of spring force and gravitational force, determines its motion. The change in total energy is computed by subtracting the initial energy from the final energy. Comparing the results of the computational and experimental models, the computational model predicts the motion of the oscillating mass with reasonable accuracy. However, when comparing the two, the peaks and troughs of the experimental data do not entirely align with the computational model. This discrepancy can be attributed to effects caused by air resistance or drag, which were not considered in the model. Including a drag factor could improve the accuracy of the predictions. In terms of energy conservation, I believe the total energy of the system is conserved. Considering the mass, spring, and earth as part of the system results in a consistent change in energy, as indicated by the horizontal orange line. Also, when analyzing the average oscillation periods in the x and y directions, we observed that the time periods for oscillation in the y direction were slightly shorter than those in the x direction. This could be due to the higher influence of gravitational force in the y direction, which might result in shorter oscillation periods. Finally, I would like to acknowledge the resources and tools used in this experiment, including tracker software, glow script for coding, and the lab instructions provided by my course. Thank you for watching.